Hey, sixth graders, we're going to take a look at how we can use probability to make predictions about things that could potentially happen. So recall theoretical probability tells you mathematically what should happen, while experimental probability tells you what will actually happen. So we can apply this theoretical probability of what should happen to these events. So let's say I want to flip a coin 100 times. I can predict approximately 50 times I would get a heads because the probability of flipping a heads is half. So that means half of the time I would expect to get a flip a heads. Now, is that going to be the case always? Absolutely not. We're not living in a perfect world where that theoretical probability will come through every time. So that's where the experimental probability, it will differ from theoretical, but it should be pretty close. You know, if I flipped a coin 100 times, you know, I wouldn't just get heads 2 times and tails 98 of the times. So it should be about, you know, I'd say I'd get heads probably between like 40 and 60 times in that range, because that's pretty close to the 50% of the time. So how can we make these predictions and figure out approximately how many times we think something might happen? Well, we can use our equivalent fraction skills or our proportion skills. And if you recall back to when we solved proportions, we can use that cross product and solve for the unknown thing, the variable. And that is because what we're doing is we're assuming that the theoretical probability of one event happening will be approximately the same as if that one thing happened multiple times. So let's do some examples to help this make sense. So what is the probability of rolling a 2 on a 6-sided cube? Okay, so there's 1 2 on a 6-sided cube, so there's one option out of 6 total options. So 1/6 of the time I can expect about that I'd be rolling a 2. So here's how we can apply this probability to figure out, okay, so how many times do we think we would get a 2 if we rolled this cube 30 times? Well, we can actually assume that we will roll a 2 1/6 of the time. So this is another way that we can solve this, is also by multiplying. So there's 2 options, and I'm going to show you both of them. So I can do 1/6 times your 30 rolls over 1. I multiply, I get 30 over 6, which is equivalent to 5 times. So I can expect that I would roll a 2 about 5 times. And here's how I can use the cross product and the equivalent fraction skills that I mentioned. So 1/6 is going to be equivalent to, so remember, this is the 1, 2 out of the 6 total. So I can set up my proportion and have my 30 total and my unknown amount of rolls of 2. So now I can use that cross product or equivalent fraction skills actually. So we could do it either way. This one's pretty easy. I can go from 6 to 30 by multiplying by 5, and I do the same thing to the top, and it's x equals 5. If we use the cross product, just to kind of review, what we would do here is 6x equals 30, and that's a one-step equation, divided by 6, and we get x equals 5. So in all 3 of these methods, we can expect that we would roll a 2 5 times. Let's do some more examples to help it make sense. What is the probability of flipping a tails? So you have a coin, heads and tails. You have 1 heads out of 2 total options. So 1/2 is the probability of flipping a tails. We're going to use this probability to predict how many times we would flip tails if we flip the coin 200 times. So again, we can assume that based on that one basic probability, we're going to apply that and assume that we would get a tails about half of the amount of times that we're flipping the coin. So again, I'll show you 2 different ways. So we can solve this by doing 1/2 times your 200 flips. You can cross simplify or just multiply straight across, and we get 100 times. We can expect that we would be flipping a tails. But we can also do equivalent fraction route. So 1/2, remember the 2 is the total. the total options. So, and this is going to be the total amount of times we're flipping, right? So that's also the total, and the unknown is up here. So x over 200 is equal to 1/2, multiply by 100, multiply by 100, and we get x equals 100. Oops. And again, you could solve using the cross product. I think that's a little bit more time consuming. I prefer the multiplication route because I think that's the quickest way, but you can do whatever you prefer. And let's see, this will be our last example together, and then I'll let you do the backside on your own and check the answer key on the website. What's the probability of spinning a 4 or a 5? So let's see, we have 8 total options, and to get a 4 or a 5, that's 2 options. So that's 2 out of 8. I'm gonna go ahead and simplify that because that's gonna make my life easier. That's a quarter of the time. So the probability of spinning a 4 or a 5 is a quarter. And interestingly enough, it does make up a quarter of the spinner. So let's use this probability to predict how many times we'd get a 4 or a 5 if we spun it 40 times. So we can expect we will get a 4 or a 5 a quarter of times the time. So 1/4 times 40. I know a quarter of 40 is 10 times. If you want to do equivalent fractions, it's going to be a quarter is equal to some amount out of 40 total spins. And you would multiply by 10 times 10, and x equals 10 yet again. So this is a pretty straightforward, nice application of the theoretical probability and how you can use it to make some future predictions if you were doing some of these experiments multiple times. So go ahead and complete the backside on your own and check the answer key on the website.